This is TechSNAP, episode 420, for January 10th, 2020. Hello and welcome to TechSNAP, Jupiter Broadcasting Systems, Network, and Administration podcast. My name is Wes, and I'm joined by Jim.
What's up, everybody?
Well, Jim, it's a new decade and one that promises to see the continued rollout of 5G here in the US. But for the past year, South Korea has been living in the future. And according to recent reports, it's not quite the future they had hoped for.
According to the Wall Street Journal, at the end of June 2019, South Korea had tacked on 1 million 5G subscribers in only 69 days of offering it.
And by year's end, that had grown to almost 4 million subscribers. This sounds like it might be an interesting test case for 5G, and indeed it might be, if you can actually manage to figure out what technology's been deployed where. Jim, you and I both have been looking into this, and unfortunately, details are scarce.
Yeah, they really are scarce, and a lot of it is the same confusion that you run into every single time you talk about 5G, which is people just say 5G. They don't talk about whether they're referring to the FR1 bands, which are sub 6 gigahertz, and, in RF terms, behave just like 3 and 4G did because they're on the same, general spectrum with the same characteristics. Or they're talking about FR2. FR2 is also referred to as millimeter wave. It's in the extremely high frequency band. It's effectively a little bit sub-infrared, and it behaves very, very differently. Now, the bandwidth of channels in FR2 is extremely broad, and so you can have very high throughput if you can get a connection, but you need an absolutely clear line of sight to a tower. Any wall, window, human body, you name it, is going to break that connection. You also need to be stationary. Moving targets do not do well with 5G FR2. So there's always a lot of confusion when you see people saying things good or bad about 5G and actual implementations. Well, are we talking about FR1 or are we talking about FR2?
So far, the most popular model to support 5G seems to be Samsung's Galaxy S10 5G, which does have support for FR2. But you're right, Jim, where can you use this tech if you have to be standing right in front of a transmitter? Now, there have been some rumors of deployments in very dense urban areas, think game stadiums, but you're also seeing some confusion from customers when they leave those areas and suddenly find themselves back on LTE.
So, Wes, as usual, when you see reporting on 5G, the Wall Street Journal, Samsung's press about it, basically nobody, when they cover South Korea's implementation of 5G, really talks about whether either the good things or the bad things are, happening to users who are on FR1 or FR2. All we really know, according to the Wall Street Journal's reporting at least, is that the Korean users aren't happy about it. They quoted a gentleman named Mr. Jang, a 30-year-old tech company worker, who said he does not feel a difference when he enables 5G. And he says he usually switches it off altogether because his connection tends to drop as his phone ping-pongs between 5G and the existing 4G LTE network. So he feels like he's getting a better experience if he just turns 5G off entirely and just stays on 4G so things always work. Now, is that an issue in that when he's got 5G enabled, he's on millimeter wave and his millimeter wave connections keep breaking as he moves around or, turns and interposes his body in between the phone and the tower? Or is it, a bigger problem with even 5G on FR1 not wanting to stay connected? We don't know because nobody ever reports this stuff accurately.
I'll admit to being pretty surprised by the lack of details in some of these articles. Articles that even include many other technical details still don't manage to specify which frequency range they're actually talking about. I have heard some rumors that at least one of the major carriers there has been rolling out millimeter wave 5G technology, but mostly in large indoor areas. And even that has required creating specialty hardware to deal with things like walls.
The most polite way I can characterize the coverage is lacking in technical detail. These reports of negative experiences from users could mean either of two things, and we don't know which. When we hear that 5G connections keep dropping and, people's phones reconnect to 4G, that might mean that they're having entirely predictable issues with FR2 that are just never going to change because of the radio frequency characteristics of the EHF band. Or they might mean that the actual progress of, the reasonable person's 5G, the FR1 that operates with the same radio frequency characteristics that we're used to and can actually penetrate walls and go inside buildings and, work in moving vehicles and the whole nine. The big promise of 5G FR1, and there really is one, is that, much like Wi-Fi 6 is in theory supposed to work much better with, really device dense areas where you've got a lot of people all connected at once in the same general area. 5G FR1 is supposed to offer that as well. So if these South Korean users are on 5G FR1 and they're still having these drop-offs and problems and not seeing a difference from 4G, that signifies a really big issue. And it's one that I wish we knew whether that was the case or not, but we just don't.
Well, for the moment, at least, it looks like it's still something of a waiting game to see how rollout of 5G continues. And while we wait, Jim, I'm sure we'll both be looking for some stories with some better technical details.
I am truly anxious to know the answers to these questions about 5G FR1 and about, Wi-Fi 6, aka 802.11ax, both. Because both of them promise very similar things that are desperately needed about better serving areas with tons of people and tons of devices. And right now, we're still just stuck in this waiting game of maybe it'll actually work and maybe it won't. I want to know.
Let's continue on in this first episode of the new year. And a new year brings time for reflection. Debian's been doing some reflection, it seems, with a recent vote on the status of their adoption of systemd.
Basically, Debian wanted to make sure that everybody really meant it and was okay with it going forward, focusing on systemd as a replacement for sysv init, because there's still a lot of controversy about it.
Boy, how time flies. I can't believe that heated systemd debate was only 5 years ago.
Yeah, 5 years. And yet the controversy has still not died down. Well, honestly, because there's still problems with systemd.
Problems in software, Jim? You've got to be kidding me. But before we get a whole bunch of complaints, maybe you should go on and tell us a little bit more about what you actually mean.
There's a lot of people that get the controversy pretty wrong on both sides. I see a lot of people that just argue that there's nothing good about systemd and it, never should have been a thing. And, rah, 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 rah. And in reality, systemd fixed a lot of problems. It made it possible to boot systems a lot faster. It made it possible to trigger events in more accurate ways and based on different circumstances that you just couldn't really get without the kind of overarching infrastructure that systemd provides. But the valid complaints about systemd, for one thing, a lot of people aren't happy about the binary logging format. Now, you can nerf that. You can force systemd to log in text. Honestly, I don't even really care that much if it does log in binary because the binary format can be read and parsed back out to text. That's fine. The thing that I really don't like about systemd is it's much, much, much less discoverable than sysv init was.
While I certainly appreciate not having to write custom shell scripts just to start my applications, I will admit that when things go wrong or you just want to customize things a little bit more than the config file offers, systemd can be a bit of a beast. You've got multiple layers of documentation, not to mention the C source code beneath everything. It's just not quite as flexible and hackable as a shell script sitting right in front of you. And I can understand how, for some veteran systems administrators, all this effort might not be worth it.
Yeah, you're going to have to go find some documentation somewhere, and a lot of it's just not really available. It's part of the eternal battle between sysadmins and developers. For all of its pros and cons, I feel like sysv init was clearly a product of people who were sysadmins at heart. It's all about operating the system. Systemd was written by developers for developers, and that exposed a lot of great functionality that you can use when developing new applications and new tools, but it also makes just operation of the system from a sysadmin perspective, it's a lot more of a pain in the ass. One really great example of that is the difference between saying, okay, I don't know, maybe I need to bring a firewall up, immediately prior to bringing up the network interface. Well, prior to systemd, that was really easy. Like on a Debian or Ubuntu system, you go into etc. network if pre-up.d and you drop a shell script in there. Done. It's going to get run immediately before the network comes up. Or if you want something to be done immediately after the network comes up, you drop a shell script into etc. network if up.d. Similarly, there's if down.d and the whole nine. But this is all very easy and very discoverable. You want to know it's there? Just look in the directories, etc. network. Look, there's these directories. These things happen in it. Now you have to write a systemd unit. And your systemd unit has to be triggered by a particular systemd trigger. And this all sounds great, but from the perspective of an admin who's just trying to make the machine go, now instead of saying, okay, well, I can just look in these directories and it's very obvious I can drop a shell script in here and it will work. Now you need to look at systemd man pages. You go to freedesktop.org/software/systemd/man/systemd.unit.html. Buckle in, you need to read a novel now on all the different things and all the different syntax and all the ways that you have to write this arcane thing to just start a service when you want it to.
Jim, another factor that made this whole debate more difficult was that at the same time systemd was being adopted, many operating systems made other significant infrastructure changes. I'm wondering if any of those factors might have added to your systemd consternation.
It's not entirely fair for me to blame systemd on the lack of Etsy network if up.d and if down.d and all those kind of things. My personal pain has been with Canonical's NetPlan, which they just happened to implement that in Ubuntu at the same time that they implemented systemd. But NetPlan is actually a Canonical package, and it's Canonical's own thing, and it looks like the rest of the world wants nothing to do with it, much like Unity. Unlike Unity, which I quite liked after a little bit of tweaking, NetPlan's kind of a nightmare. One of my big issues with it is the configuration is YAML, and I griped about this in Nebula. I'm going to gripe about it again. YAML is just never the correct answer. A config markup language that parses white space and will break if you have one leading space too many or too few on a line of a config file, it's just wrong. It's never going to be right. It's not okay.
All right, well, besides the semantic spacing, which I'll agree can be kind of annoying, at least without a good editor, what else don't you like about NetPlan?
Those two things are the big things. I really, really, really miss Etsy network if up.d and if pre-up.d. It's a never-ending pain in my butt that those are gone. Systemd triggers are just not a decent replacement for that. And YAML. Other than that, I've learned to do all the things that I need to do with the actual config file, as is typical for systemd as well as NetPlan. It's not well documented enough. I probably spent 4 hours figuring out how to implement bridges with multiple VLANs on NetPlan. There was documentation that theoretically covered that, but none of it actually worked or had usable examples. And so I ended up spending several hours figuring it out because I desperately needed to, and then, publishing an example file in a blog post. And as far as I can tell, my blog was the first place in the world that would show you how to do that. I don't really appreciate things going out into production that require that degree of work before literally anybody knows how to use them. I don't think that's okay either.
It does seem like a lot of these choices are inspired by complex networking scenarios, like you might find in large cloud environments. And those are certainly legitimate problems to solve. But a lot of the design choices, configuration languages, programmatic interfaces, it makes me think that for folks who are managing single boxes or just looking to use these tools in simpler configurations, what you might call a classic system administrator feels like they've been left behind.
So, Wes, I guess the next question is this Canonical only project for configuring your network interface? Is that eventually going to go the way of Unity? Canonical did that thing for Ubuntu and soldiered on bravely with it for 3 or 4 years. And, will they then end up giving it up and dropping back to Network D or, I don't know, IF up down? Who knows? Oh, that's right, Wes. This wasn't just about me griping about systemd. This was actually about Debian, wasn't it?
Yes, it was. And clearly there are some problems with systemd, and there are other init systems out there. But there is a cost to having multiple init systems, in bugs, in maintenance, in packaging. So it's worth thinking about, is it worth the cost?
And in true Debian fashion, they took votes on 8 different options and parsed them according to an algorithm and then told us what the short set contained at the end. And, what that all actually means is, from options like focus on systemd, but support exploring alternatives. Support for multiple init systems is important. Further discussion only on down the line. The option that was the most popular with the most people was focus on systemd, but support exploring alternatives. And probably the most important thing to note about this is two of the alternatives that were not chosen as the winner out of these 8 separate. Option 1 was just purely focus on systemd, and it was not a winner. Option E was support for multiple init systems is required. It was also not a winner. What we came up with was systemd, but we support exploring alternatives.
Moving right along, over at Phoronix, Michael Lairball points out that one of the interesting milestones last year in the compiler world was the ability with LLVM Clang 9.0 to compile the Linux kernel, at least versions 5.3 and above, for the x86-64 platform without needing any extra patches to either the compiler or the kernel. And, of course, Michael goes on to do a lot of interesting benchmarking, which we can get into. But, Jim, it made me think that before we do, we really ought to talk a little bit more about Clang and why you might want to go to all this trouble to use it to compile the kernel.
That's a great question, Wes. Honestly, I think in the real world, the typical answer of why you might want to compile something with Clang other than GCC, there are some technical reasons, but what I encounter most frequently is devs that just hate the GPL and they don't want to use a GPL licensed compiler. They want to use something with a weak permissive license, which that's Clang.
There are certainly some parties out there looking at you, Apple, who are not so fond of the GPL. So we should be clear about this. What license does Clang use?
That is also a great question, Wes. And it seems like the folks who write and develop Clang are maybe the most confused about it. Clang was originally released under the University of Illinois, I believe, NCSA license, which is a weak permissive license. And then eventually the project was ported over to the Apache 2.0 license with a couple of exclusions that are aimed around making certain that the project can be kind of mixed and matched with GPL code if necessary. The really annoying thing is that what you usually hear people say is that Clang is BSD licensed. And in fact, the Clang page itself at clang.llvm.org, in its comparison between itself and the GCC, says Clang uses a BSD license. It does not. The Apache 2.0 license is not a BSD license, never has been. It and the Apache license are both weak permissive licenses, but honestly, Wes, it kind of makes me salty when somebody is that cavalier and mistaken about their own license and their own documentation. It's not the BSD license, it's Apache 2.0.
Yeah, there does seem to be an unfortunate amount of confusion around that particular issue, so it's good to be clear.
The way that you are certain for the record, and what we actually did to settle this question, is actually browse through the Clang repository to llvm.org and go through the source tree and look on release 90 and see the license.txt file, which is Apache 2.0 with 2 LLVM exclusions.
Well, you're certainly right that licenses can be quite divisive, but that's not the only reason you might want to use Clang. Clang is part of LLVM, and as such, it's a modern compiler with a modular architecture. Now, GCC is of course a great compiler as well, but it's quite a bit older and has a monolithic design. This can make it more difficult to integrate with things like IDEs or static analysis tooling. Things that might draw you to Clang include fast compilations and low memory use, expressive diagnostics, think really nice warning messages, and compatibility with most of GCC and its extensions. It's also got a modular library-based architecture, it supports diverse clients, and allows for tight integration with IDEs. And while GCC is great, it also has a lot attached to its philosophy, and in that sense, Clang represents a much more pragmatic approach to building a compiler.
Yeah, and it's easy to see where a developer would grow much fonder of it based on that alone. Even if the performance of the compiled object code is roughly similar between Clang and GCC, And it certainly looks like, from Laravel's analysis and benchmarking of, Linux kernels that were compiled with both Clang and GCC, the performance levels are pretty similar. You got basically plus or minus roughly 10% spread for the giant barrage of benchmarks that he threw at it, with a couple of minor exceptions, but probably not enough to really feel like, this is a giant difference anywhere. However, the actual compile time is much lower. So it's easy to see where, if you're really a rubber meets the road developer and you're having to compile and recompile your project as you're working on it through the day, the tool that does the actual compilation a lot faster is probably going to be one that you prefer pretty strongly.
Absolutely. And if you happen to have something wrong with your code, which, happens to the best of us, the great static analysis tooling and debug output from Clang will also be very useful. There's another interesting reason that you might want to use Clang, and that's because building code with another compiler is a great way to shake out code that relies on undefined behavior. Since the C language specification does not define certain behaviors, compiler developers can choose whatever happens to be convenient. So adding Clang into the mix can make the kernel better just by compiling with a different tool. The reverse is also true. As we all know, the Linux kernel is a pretty gigantic C codebase, so getting all of that working with Clang can find bugs in the kernel and find bugs in Clang and LLVM. And I think that's one sign of a great goal. All three projects are getting better, and at the end of the day, there's really the principle that competition is generally good. We're lucky enough to have two great open source compilers. It'd be foolish not to take advantage of that.
It's the same thing that we see with, there's a constant developer argument over whether or not it's worth it to build your project multi-platform because, now you have to do all this work of making it multi-platform capable. But the real answer there tends to be it's not that much work to write your code cleanly where it will compile and function well on multiple platforms if you start out with that goal. The real pain is when you've built something that depends not only on the features, but on the implicit bugs of one particular platform. And so it's kind of lost in a drift when you try to run it anywhere else. And it's good for your project to avoid that. Writing for multiple platforms forces you to write code more cleanly and more logically and just well-structured in the first place.
It's pretty exciting. After all the hard work and changes, these days, at least on x86-64, all you have to do to get your kernel compiled with Clang instead of GCC is change what CC points to in your makefile. That's it. As a final note, Google has put in a lot of work getting the kernel to compile cleanly on Clang, and it seems to be paying off for them. They've been shipping a Clang-compiled kernel on Chrome OS since 2018, and you'll find it running on the latest models from their Pixel line. If you'd like to find out more about their efforts, we'll have a great talk from some of their engineers from FOSDEM 2019 linked over at techsnap.systems/420. That'll do it for this episode, but don't worry, there's always more TechSNAP over at techsnap.systems. There we've got show notes, the whole back catalog, and easy ways to get in touch. If you'd like more Jupiter Broadcasting, just head on over to jupiterbroadcasting.com. where you'll find all of our latest shows, and in particular, go check out Linux Headlines, which is freshly back from our winter break. If you'd like more Jim, you can find him writing over at Ars Technica. Jim, you're on Twitter as well.
At JRSSNet.
I'm there too. I'm at Wes Payne. The whole network is at Jupiter Signal. Thank you for joining us.
See you in a couple weeks, everybody.